Thank you guys all for coming by. Today I want to talk a little bit about how to write distributed Scala applications with Mesos. And a little bit about me. So I used to work actually with Marius at Twitter. And I worked on user search there. I sort of helped bring Ben into Twitter because I've known Ben, who's one of the main authors of Mesos. I've known him for a very, very long time, 13 years. And after Twitter, I went over to Airbnb and built out the data infrastructure team. And there we built logging systems, ETL pipelines, pretty standard stuff. But we also built Chronos, a framework that was built directly on top of Mesos. And that was actually really fun. So the other stuff was fun too. But yeah, and now I moved on from Airbnb and I'm working on a startup around Mesos. So yeah. I'll tell you a little bit about the structure of this talk. So I kind of want to go through the state-of-the-art deployment of apps and cluster management initially. And then I'll give you a brief intro to Mesos and how it works. And then we'll actually do something a little bit more hands-on that you can follow along. And it's basically how to build a framework in Mesos. And if you have a laptop and you want to check out this URL in the meantime and start building, because you'll need to likely compile something, which takes a while, you can go ahead. Otherwise, you can just follow along and do that at home afterwards, if you care to do so. And yeah, so how many of you guys have actually tried to play with Mesos before? OK, so about like a third or so. Cool. Awesome. So, well, first of all, kind of the motivation behind why Mesos was built. Generally, when you start with a data center, or when you start as a web business, the first step is to provision VMs on either public cloud or on your physical boxes on the bare metal. And what that leads to is you start out with maybe 10 boxes, and then all of a sudden you have 40 boxes. So you have more stuff to manage, but you get finer granularity. Then you usually use something like Chef or Puppet. That's, I think, pretty common nowadays to set up and launch Hadoop, maybe Ansible. So you set up your Hadoop cluster. And then you decide we also want to serve a website, because we don't have any log data. So you're like, well, we'll use JBoss because we're an enterprise company, or Rails or Sinatra. So you basically provision your JBoss cluster. And you already see you have now two statically partitioned subclusters, basically. And now you get a big hit on TechCrunch, and you need to crunch a lot of logs. So you actually resize your Hadoop cluster. And the resizing is actually pretty painful. I don't know if anyone here has done a resize of Hadoop. It's actually not as seamless as it seems. And well, what you end up with a larger statically partitioned Hadoop cluster. And yeah, so what's the problem with this? Well, I mean, obviously that works, and a lot of companies are doing this right now. But it's really, if you see all the steps involved, it's really difficult to deploy new frameworks. You have to provision, you have to set up, you have to install, you have to resize. And also the static partitioning leads to really low utilization, and it prevents elasticity. And I'll show you in the next slides why that is. So let's assume you have your Memcache cluster, you have your JBoss cluster, and you have a Hadoop cluster. And most of the processing, at least at Airbnb, that we did, the automated batch processing, took place at night. Whereas the peak of utilization, where people actually checked and started to book an Airbnb, was during their working hours, of course, because nobody loves to do work. As you can already see, during this time, the Hadoop cluster has really low utilization. And during nighttime, basically the JBoss cluster is not very busy. So before we jump into how it looks with Mesos, let's give you a little bit of background about Mesos. So with Mesos, you get fault tolerance, you get scalability to tens of thousands of nodes. You get isolation between tasks by using Linux containers. You get basically a multi-tenant cluster. And the APIs that are available are Java, Python, C++. I think Shopify just released Ruby bindings. And in general, Mesos has a coordinator worker architecture. So basically, you have a bunch of workers that feed the resource offers into the master. And I'll show that in a slide further down. But I guess like also, why should you care about this? There are a couple of companies that are really using Mesos in a big way. I think the biggest user right now is Twitter. I think they're using 5,000 or 6,000 nodes. I don't know, is that about right? At least, yeah. So and I think at Twitter the entire ads infrastructure runs on Mesos. So it's a serious. I mean, ads is very serious for Twitter. So all of that stuff runs on Mesos. And at Airbnb, on the other hand, all of the analytics infrastructure now runs on Mesos. And job orchestration is done by a tool called Chronos. Cronus is it's basically a distributed cron with added support for dependencies and fault tolerance, and well, it's distributed. And I can show you a little demo later. But many others also run Chronos dpark. Dpark is a Python variant of Spark, and yeah, so it's really gaining a bunch of momentum. But to come back to this slide that we saw earlier about the resource utilization, with Mesos, hypothetically, you'll have something like that. You can really leverage the peaks and troughs by basically merging your entire cluster into one large resource pool, and you can obviously also give different priorities to each of them, to each of these frameworks, but this is essentially what the view of your cluster from Mesos. And if you contrast that to the way that you have the view if you have a bunch of VMs, it just seems a little bit simpler, right? So that's one of the big value propositions of Mesos. And by the way, feel free to ask any questions in between. So I talked already earlier about the way that Mesos works on a high level. Basically, you have the masters or coordinators, and frameworks register with the coordinators. So an example is Spark. Spark, how many here have heard about Spark? Okay, awesome. Yeah, everybody was at the talk before. So Spark is a framework that was actually originally written against Mesos. I think it now provides a standalone mode, and I don't know if it works on Yarn as well, but it's one example of a framework. Chronos is another framework that I've mentioned. MPI runs on Mesos, and I guess what else is there? There are a couple of others. There's, for example, Storm runs on Mesos as well, I think natively. Yeah, and we'll talk about one more later as well. But essentially, the scheduling is done. The scheduling of these tasks is done via asynchronous resource offers. So when a worker comes online, it basically says, hey, I have X gigabytes of RAM, I have X N CPUs, and then this is handed to the master, and the master has an allocation policy. And according to this allocation policy, these resources are offered to the frameworks that have registered with the master. So for example, you could assume that your front-end resources or your front ends should be getting a higher weight than your batch processes, right? Because you don't want to, if a customer comes to the website, you don't want to serve a 500 because you don't have capacity because you're running a Hadoop job essentially. So you can really adjust the weight for each of the frameworks, what a percentage of the offers they basically get. And Mesos also monitors your tasks that you're running, and it will notify your framework if a fault occurred. And then it's up to you to really say, hey, I want to retry this task, or I just want to abort. And so it's really like made for writing highly available and fault-tolerant systems. So a little bit about resource offers. So resource offers are consumable. They are basically CPUs, they're RAM, and they're disk. And I think they're working on I/O as well, but I don't know what the latest status on that is. But so essentially, if your machine has 4 CPUs and one task consumes one, then you only have 3 available. And it's the same for RAM, and it's the same for disk space. But there's another really neat thing: attributes. So Mesos supports attributes, and you can basically just hand those to the slave process that you start. they're essentially just a map of string to string, and they're non-consumable. They're an attribute, so it's a rack ID. It doesn't go away if you advertise it. It's basically, it allows you, when you write a scheduler, to make a scheduling decision based on these attributes, where you want to, which resource offers you want to accept, for example. A license could be another thing that you expose in an attribute. So if you have a Mathematica license on one box, then you could run Mathematica tasks on that box.
I have a question. Going back to the architecture slide, could you clarify how all those individual pieces map to either, like, what should I say, physical machines, virtual machines, or Linux containers?
Sure. Okay. So a slave is essentially a process that runs on a box, and we've set up our boxes to run one slave per box, and these slaves can then basically fork a C group, and in that C group an executor will run, and that executor then will be if a framework, for example, sends a task to that slave, that executor will run the task. And we can, I think it'll become a little more clear in a couple of slides. Did that answer your question?
Yes.
Okay, awesome. Okay. So, well, I think it's kind of important to point out here that I've already hinted at that, but there are these two main areas that I've worked with Mesos with, and one is kind of in the request response part. So request response are your services, right? They're up and they're always running. And then batch is kind of, well, it's like Hadoop, right? You're running a Hadoop job, and Hadoop should be up for the time. It doesn't have to be up all the time, it's a task that finishes basically. And in the request response part, your tasks actually don't ever finish, at least in theory. So, and those are some frameworks that we can currently launch on Mesos. So Spark, MPI, Hadoop, Chronos are all in the batch part. I think Storm is also considered batch. And kind of to come back to your question earlier about C groups and isolation. Well, Mesos itself doesn't actually provide isolation. It leverages the isolation that the Linux kernel provides, or that if you're running on Solaris, you can use zones. So the Linux kernel, since for the past like 3-4 years, on every standard distribution has contained C groups. So you can get process isolation and memory isolation. You can get CPU and memory isolation by using C groups, but you don't actually have to do that. So for example, at Airbnb, we weren't using C groups for a while. We were just using process isolation, meaning that your process could grow its RAM until it basically was shut down or swapped. And but of course, it's really nice if you use C groups and you have analysts that like write really large queries that generally take down your cluster. If they now write really large queries, their processes just get killed. And but so another interesting aspect about this was that at Twitter we ran Mesos on bare metal, or they still do, not on top of a VM. And at Airbnb we actually ran in the cloud. We ran everything on AWS, and AWS uses Zen underneath. So you can actually get the benefits of Mesos even if you run on top of a VM, but you don't have to run on a VM.
Do you do any auto-scaling on top of the auto-scale VMs underneath?
You could do that, yeah. Yeah, you'd have to, I mean, right now you'd have to build some of that wiring yourself, but yeah, that is definitely something you can do. So, oh yeah, I guess one aspect I forgot to mention here. So, obviously, when you're running on bare metal, your host operating system can do optimizations that you can't really do when you're running on a virtual machine, because the hypervisor is kind of a black box, right? So, in general, you get much better performance if you're running on bare metal. But that's pretty obvious. So, to go back to Airbnb and kind of finish off this story on how Airbnb actually got involved in Mesos. When we were evaluating Mesos last year at Airbnb, after I've seen it at Twitter, the primary reason for using it was we wanted to move off of EMR. That was kind of the long-term strategy back then. And we wanted to first start playing with Mesos and basically introducing it. And so we wrote this system called Chronos. And Chronos ran as this distributed cron-like system on just like 10 nodes or so initially. And then we added other frameworks. So we added Storm, and now, as I had mentioned, they moved completely off EMR and run everything on Mesos. So Hadoop runs on Mesos at Airbnb. And the cool thing about that is you can run actually multiple versions of Hadoop on the same Mesos cluster. So you can give one Hadoop cluster to your research department, and you can actually like constrain the resources they use, and you can run another Hadoop cluster that runs all of your production jobs. So it's pretty nice. Yeah, and I think when we go back to this slide, I think like Airbnb is now looking, at least from some of the engineers I've spoken with, they are also looking of extending their use of Mesos to this request response part of the equation. So yeah, there was an article on GigaOM about Airbnb. So if you guys want to check it out, it's kind of interesting. They write a little bit about how I don't know if they write about how much money they're saving by running it directly on Mesos instead of EMR, but it's a really interesting read. So.
That's a good question. Does that article, like I didn't see like your group mentioned there, like is it giving enough credit to people who actually build all this stuff, or is it just an overview of things?
I think it's more of an overview of things. Okay. Yeah. I'm gonna sit down and give you guys a little quick overview before we continue here of the Mesos UI, so that you kind of maybe this makes things also a bit clearer. So this is kind of running Mesos locally on my box. I just told the Mesos slave that I had 4 gigabytes of RAM and 785 gigabyte disk. And so you see one slave is running, there's a resource offer out, and there's a framework registered, which I'll show you in a little bit. It's called Marathon. But I think what's also interesting to look at is you can actually start Mesos really, once you have installed it, you can start it really, really easily by going by, this presenter screen thing is kind of annoying. So the command line for starting is basically here, Mesos master, you give it the URL to Zookeeper, and that runs your master.
It has a Zookeeper, right? Also.
Pardon me?
It also has a Zookeeper embedded.
It doesn't run the embedded Zookeeper though. Okay. It's mostly for the library bindings. And then for running a Mesos slave, I'm setting some library path things here, but you can see here I specify the consumable resources, and here I specify the attributes. In this case, I specify I have a Mathematica license, which I actually don't. But I'm also not running Mathematica on here. It's just an example. Okay, so this is this part. Okay, but what I really wanted to start doing is I really wanted to shift the focus a little bit, because I think everything I've mentioned so far was more from an operational point of view. So I think there's also this view for developers. So in general, I think as we're building more and more distributed systems, failures happen, right? So for example, you lose a node, or you lose an entire rack, and you have to deal with that as a developer. So and I think Mesos gives you a really neat way of handling these sort of errors. And the same for elasticity. I mean, the cloud promises us all this elastic stuff, and at the same time, I see people over and over re-implementing the elasticity component. So Mesos really makes that also really easy. And having said that, let's really jump into kind of the anatomy of a framework, and we'll build a small Mesos framework. I'll sit down with this stuff. Oh, I got to give some credit here where credit is due. A friend of mine, Toby, actually came up with this tutorial originally, and I just modified it a bit. So, all right. And I'm actually going to switch to mirrored screen now. Awesome. So I don't know. Is anyone kind of like? Did anyone start doing the tutorial or give it a shot? No. Okay. All right. So how this actually works? If I find the right terminal here. Okay. So. Basically, I cloned the repo and I checked out the step 0, S0. So this is a little bit confusing. There are some tags in there, and I just wanted to upgrade it to run with the latest version of Mesos. And so I created branches, and they are called S0 through S5, in case you want to check this out yourself. So I have it open in my IDE already. And initially, there's just, I know a lot of people will hate me for this, but there's a POM file in here for not an SPT file. I'm sorry. Oh. Oh, sorry, guys. Sorry, guys. So you see this POM file. Can you read this properly, or should we turn the lights down or? Much better? Yep. Okay, cool. So basically, all I'm doing is I created like this template POM file here, and that creates an Uber jar in the end, and not much happens actually. So let's check out the first part where we added some code. So this is the example scheduler, and these are all the methods you just need to implement that are defined in this abstract scheduler class that Mesos ships with. And in fact, like only 2 of them are really interesting initially. The 2 that are really interesting are resource offers and status update. So you get a resource offer. When you get a resource offer, you can say, hey, I want to accept that resource offer, or you can just decline it. Status update is relevant if one of your tasks that you had launched has an updated status, such as like it's running, it's terminated, it failed. And there are a couple of other ones. Slave lost. Slave lost generally also results in a task loss, so you don't, unless you have some special semantics that you need to do when your slave leaves, you might be able to ignore this. But this is kind of just the layout of the scheduler. And before I actually continue further, I kind of mentioned earlier that you have schedulers and then you have executors. So Mesos ships with a command line executor that basically just forks a new shell. So you can that's what we've actually been using for Chronos and for a new framework that we've been writing as of recently. And please interrupt me if you have any questions. So we'll go through this through the next step. So we'll check out step 2. We created a main method, so a main class object, and we gave it the framework a name. We accept an input argument. It's the master URL that could be either local, which means it will run an in-process Mesos, or it's a URL to the zookeeper, including the path to your Mesos node. And we also include a command to run, because this is the framework we're building. We want to just build an init for your cluster. So where you can say, I want to launch a process 5 times on 5 different nodes, for example, and I want 5 instances to be up and running all the time. So if one dies, we should launch another one. And then we say how many instances. So these 3 arguments. So then the first thing that you do is you build a framework ID. And that's just an identifier for this scheduler, basically. And then you construct a framework info. So under the hood, by the way, protobufs are used for all of these data structures. And when you determine, you basically set parameters like failover timeout, which is the amount of time in seconds when your framework goes away, and if it doesn't reappear within X seconds, it will all the tasks will be killed. So if you set that to infinity, the tasks will continue running. If you set it to 0, if your framework dies, all the tasks are killed. Why is this kind of useful? Well, Hadoop, I don't know about the latest version of Hadoop, but the job tracker, for example, the job tracker can be seen as a scheduler. So if the job tracker dies, and if it's not recoverable because it's not HA, you also might want to just kill all the tasks because you're not going to be able to recover them. That's kind of the use case there. And all right, next step is we basically build a new scheduler. We say new example scheduler. We give it the command and the number of instances. And then we construct the driver out of the scheduler, the framework info, the master, and run the driver. And in fact, we can probably already do that. So let's see. Yeah. So here you see Mesos Scala just registered just now, and it's running. So we'll terminate it, and that should go away within 60 seconds. That should actually disappear. But let's continue. If you don't have any question, we'll go to the next step. So next step. Well, what do? We actually implement some logic here. We say, so as you see, the only method we fill in is the resource offers. So for each of the offers, we loop through all of these offers, and what we do is we say if the current number of instances is less than the number of instances that we want to be running, then basically launch a new instance. And how do we do this? We basically say how many CPUs we need, how many. I think we only set the CPUs. We don't set anything else here. Yeah. So we only set the number of CPUs we need, and I think in this case we just set it to 1, and set the command. So the command info builder basically allows us to construct just a shell command. And then we say, hey, we give the task a name, so with a task ID that we generated, that should be unique. And we set the slave ID. The slave ID is handed in from the offer. We add our resources that we need and set the command, build that. And then what we say is we tell the driver to launch the task, and we get the offer ID out and give it a list of the tasks we want to launch. So, and then we just increment our current instance count. So let's try that. What should we run? Well, let's run sleep 60. Actually, let's run echo foo temp demo 1 and let's run this. Hopefully it works. How many did I say it should launch? Oh, maybe I did that wrong. Oh, I told it to launch more, huh? I told it to launch 10. That's why you see this going up. So I only have one slave running here. That's why it takes a while to go up. But as you can see, it actually launches. It tries to launch all these tasks, and it actually can only launch 4 because I only have 4 CPUs available. So it will actually not be able to get any more offers once it has launched 4 tasks. So. And you can see there's a bunch of sleeps in here. So if we check out demo, obviously I overrode it each time rather than appending. So, okay, but you can see this kind of works. So any questions?
Really quick one. So Mesos doesn't take care of the deployment, right? You have to make sure you're
It actually does take care of deployment. So you can give it you can put a URI in, or a list of URIs, and it will automatically download them. If they're tarred archives, it will automatically untar, unzip, and place them in the local directory. So it actually does take care of distribution, and it will place them in a temporary directory that's active while the executor is active. It will eventually, when the task dies, will be cleaned up according to a global policy. I think actually the policy is not global. You can, I think, set it per slave, if I'm not mistaken.
We have like frameworks such as like Hadoop or Spark, other things that you don't want to download every time.
Yeah, or like you can actually give it a HTTPS URL, and I mean like HTTPS is super fast, right? Like even if you have to download 200 megs, I mean that's pretty quick. And otherwise you can do some bash magic and figure out if it's there already and down. I mean you don't actually have to touch any of the Mesos code. You can make all of this work outside of Mesos, and that's what we actually did at Airbnb. So we did some local caching, and we wrote some fancy bash scripts that took care of that. So
question.
Yeah.
So how does Mesos itself provide HA?
You can start multiple masters. Okay, so as many as you want, and one will be elected leader. All the other ones will do a redirect to the elected leader.
Okay.
And so basically, if you want to go to the web UI, you will be redirected to the master's web UI after a couple of seconds, and yeah, and then you can also run as many slaves as you want. So that's how it's highly available.
Can you write a framework for Mesos slaves and masters to ensure that masters are out?
You could actually do. You'd have to bootstrap it somehow. And I think the latest version of Mesos actually has a little hack in it where you can actually execute, you can actually bring up a framework with a single command, and the timeout of the framework is just infinity, so the task will always be up and running. So, but yeah, so you could essentially do that. But I mean, you kind of need to still get the slaves onto the boxes and need to get the initial slaves started, right? Like, because they need to, the boxes where you want to start this. So I mean, yeah, you need to start the slave somehow in that box so it knows to communicate with the master.
Suppose that you have two tasks that are quite large, and there's not enough resources to run both of these tasks simultaneously for like their minimum requirements. How does Mesos resolve like which one should run first?
So it's like I mean, whoever has the higher priority of the frameworks will get the first resource offer, and if that framework accepts the resource offer, then the resource is consumed. So guaranteed
that one will always have a higher priority?
if you give it the priority, yeah. I mean, but it actually, how it's implemented right now, it's like I think it's weighted fair sharing. So it's like so it's not guaranteed. But there's in the current master there's a patch in. It's called resource reservations. Resource reservations are really cool because they actually allow you to guarantee for a framework that framework gets resources on a given box. So these resources are then pre-consumed and no other framework can take them. So and that's actually like I played with that last night. It's working. So I mean, according it's working in a test setup. I think actually Ben also told me that it's work. I don't know. You guys are probably using it already at Twitter. Yeah.
In the same line, so let's say my app wants this set of resources in order to run, and it needs all of them. So it's all or nothing. Basically, it either gets all the resources, or it gets nothing and then it doesn't consume anything. Can you specify a set of resources with which I will start, or I will not actually consume them?
Oh yeah. So you can say, hey, I want X amount of RAM, X memory, and X disk, and then it's like a and for all of them. Yeah. There's actually no way to. I mean, you would have to do some magic in order to do an OR, like because generally, yeah, you want your process probably consumes all of them. So. Yeah.
So how does the application auto-scale within Mesos?
An application actually doesn't auto-scale within Mesos. So the scaling becomes really easy because you can add slaves on the fly, and these slaves will just advertise their available resources to the master, and then they can run tasks. So you don't need to reconfigure your application in order to launch something on those slaves, because really the idea here is that we don't care what if this is a box, if this is a physical box, or we just care about this pool of resources, and you can add to that pool. But it's really up to your application to scale, and the application, when I say application, I mean like your framework, like the framework we're building right now. It's really up to that framework to decide how to deal with if it is how to basically deal with claiming more resources.
So see, it's the application's responsibility to decide how many resources you will get.
Yes. Yeah. Okay. Let's go to let's check out the next thing here. We're almost done with this one, and then I want to show you guys something else. So okay, we'll check out S4. Well, what does S4 do? We added some. This is a really low resolution, really hard. Sorry. So basically, yeah, we basically say, hey, if we now add kind of the ability when a task dies, we can restart them. So let's try this out. Actually, am I still running here? Sorry, I really can't see much on the screen right now. Okay, let's start it. So what we do is like when we kill one of these processes that's supposed to be running, and actually let me make this a little bit more clear because what we'll do, as you see, I'm specifying we should run 10 of them. Let's just run 2 of these, and let's actually append. Okay, so it's supposed to run two times the sleep statement. And by the way, like one of the things, like when you run Zookeeper on localhost and you have a bunch of other Java processes running, it's kind of sometimes there's a little bit of a weird behavior where your Zookeeper drops the connection. So just if you see that, this is likely a Zookeeper related thing. Okay. So because we had I think we haven't handled in our framework the case yet that so a task was already running, it was already scheduled to run, and since the timeout of the framework is 60 seconds, that task was not killed. Now it's killed because we are over this threshold. But let's say, so now we want to run this fancy program that we wrote, this echo and sleep program. We want to run this 2 times in our cluster all the time. So let's kill one of them and see what happens. So let's kill this. Okay, so first of all, let me reconnect my framework here. I don't know. Live demos, so much fun. Okay. So I think maybe it started right up again. So well, let's kill another one. So if we look in here, it has finished 2 of them. It started 2 more. So there are 2 of them running. Okay, so you see, like even if you kill them, they come right back because of our logic here, where we get the status update. And let's go through those logs really quickly, just so you actually believe me. So received status update task running. And do we actually print this out here? Task failed. Here we saw there was a task failed because we killed it earlier, and then it started back up. So there's a last step, and then I S5. So what we added was, oh yeah, this is kind of neat. This is the last thing I kind of wanted to show. As you might have seen, right now we don't actually persist the number of tasks that we want to be running. But Mesos provides a pretty neat abstraction. It provides a state abstraction. So this is basically a replicated state, and it can be either backed by Zookeeper. So right now it's for the Java part of it. It's only backed by Zookeeper, so it's only backed by Zookeeper. But the guys at Twitter actually have written a replicated log that is actually shipped with Mesos, and I think eventually it will be backed by that. That's backed under the hood by LevelDB. So. But in fact, Chronos uses the Zookeeper state abstraction. It scales quite well. So okay, so as you see, this is the framework. Go play with it, download it if you want. I wanted to show you something else that we were working on that is related. So, showed you this. I don't know if has anyone heard of Chronos? It's this tool, this framework that we wrote as well. Yeah. Okay, cool. So another thing I wanted to show you is this Marathon framework that we've recently built, and this is the last thing. So Marathon is actually it's something that it's like the init for your cluster, like or run it for your cluster. What we just built, but it has more features. So let's start this up. Okay, so we see Marathon is running. We terminated our other framework. So what does Marathon allow me to do? Well, let's say we want to run Chronos locally. I hope this works. Okay. So as you've seen, I've just used this command line tool that we built for launching stuff with Marathon, and now we can see if it actually launches Chronos. Oh yeah, so Chronos is running in this cluster. Sorry, the screen resolution is so bad that the UI is really terrible. But so yeah, Chronos is running, and you see here, wow, we're running this. And I cheated earlier. I actually launched another framework. I launched Sinatra the same way, and that was persisted, so it actually brought up Sinatra as well. And what I can actually do in order to show you what's actually running via Marathon, we can take a look at this. So we're also running a foo command, fancy program, but this also shows you the ports. So for example, if I want to connect to Sinatra, hello world. So we basically launched a Sinatra, but it's pretty nice because we can also scale those. And this is the part about the scaling that you had actually that someone had mentioned earlier. Okay, so Sinatra and 2H so what should now happen is I should have another Sinatra up and running, and I will query my endpoints to figure out where that other Sinatra app is running. Oh, there's another one running on, so there's one running on 31001 and 31000. So let's try this out. Yeah, so same fancy app that's running. And actually, one more thing, we did build. Now I have to figure out where Marathon is actually running. I actually know that. So we built a UI. I don't know. I think the resolution is going to be terrible, but we built a UI for Marathon last night, and that gives you here. This is kind of the UI. You see the applications that are running. You can launch a new application. For example, I could launch a dupe, but I'm not going to try that because it's likely going to fail. Unfortunately, the resolution is really terrible. Is this better? And it's not very bright. But essentially, what you can do is you can put in a URL here. You could put in well, what we can do is we can just kill Chronos here. All right, bye. Okay. So, okay. What I need to do is so this is the command I can run. So first of all, you should trust me, Chronos is no longer running. It's dead. We paste this is not the URL, this is the command. If I do a typo, please let me know. Okay, so I don't know if this is going to work, but we'll see. Oh, wow. Unfortunately, it's dying. Why is it dying? I kind of knew that was going to happen. All right. Give me 1 second. We'll figure this out. I think there's something wrong with it. Well, the UI doesn't work as well as I thought. So maybe this was the issue. We'll see. Oh no, I remember what I had to do. I had to do some crazy stuff with the LD library path. Gnarly. All right, we're almost there. We'll try this again. And by the way, as a URI, you could be putting a HDFS, FTP, HTTPS, whatever you want in there. S3 is not supported right now, but you could. Okay, let's try this again. This should work because you've seen actually that it works via the command line interface. So. But actually this time it works. I must have written something. I must have put something weird in there. So now it should be up and running again. Oh yeah. So here we go. No, it died right away. Why? It was running for a second, wasn't it? So, for some reason, the Cronus launcher doesn't like to run right now. Well, you'll just have to trust me that the UI looks pretty and will eventually work. But anyways, I'm going to move on because I don't think it's worth your time to debug here right now. But yeah, so that's kind of Marathon. We'll release actually Marathon pretty soon as an open source project. And if you guys are interested, I think Twitter is also releasing their project, which is Aurora. It's kind of it has many more features than Marathon. Marathon is kind of the Sinatra, and Aurora will be the Rails. And yeah, so I guess
Is there a date for Aurora release?
Marius, do you know when you guys are releasing that? But anyways, there's some resources on the stuff that I have been talking about. I hope you guys enjoyed the talk, and let me know if you have any questions.
Just a really quick one. The quick picture that we're getting is that with Mesos you have Chronos, you have Aurora / Marathon, so everything can actually launch bunches of apps in one cluster. What about considerations, load balancing, discovery,
So we have built something into Marathon. So one part of Marathon that I didn't show you because we don't have a UI yet is we have HA proxy configuration into Marathon, where we have a local, and in fact, while we were at Airbnb, we did that already. So basically, all of the hosts run HA proxy in TCP mode on localhost. We don't rely on Zookeeper. Well, we rely on Zookeeper, but we pull the Zookeeper configuration, dump it into an HA proxy configuration, do a graceful restart or reload of the configuration of HA proxy, and then basically any app can just connect to a global port on localhost and will be directed to the right server with a different port. So it's because whatever port Mesos gave you as a resource, and yeah, so that actually works, and we're going to open source that as well. So Yeah.
What kind of, I should say, like, it seems like 5,000 machines, what kind of task churn rate is that like on a daily basis? And does it do better with long-lived tasks, or
So-
can you churn many tasks?
So load tests of Mesos have shown that you can run on the order of tens of thousands of slaves with 200 frameworks, and still get scheduling in less than 1 second. So yeah, I mean it's really fast. If anyone is a C++ hacker, you should check out this. My friend Ben wrote this library that Mesos is heavily leveraging. It's called libstout. And libstout actually looks a lot like Scala. It makes your C++ code look really cool. It has tries, it has option, and all of that stuff. So you should libstout. It's github.com/thirdparty/libstout, like stout, like a beer.
Yeah, no question. So you can add tasks on the fly.
Yeah.
Right? So can you also like increase the, like let's say you have a framework running and it wants 10 CPUs, can you bump it up to 20 CPUs on the fly?
You could do that in your framework. I mean, yeah, you could do that in your framework. Actually, that might be a pretty cool feature also for Marathon, because right now you have to give it when you launch your job, you have to give it the resource consumption it wants. And it should, yeah, I think that'd be a great feature to add. Yeah. Cool. Well, thank you guys for joining.